Everyone, this is Ashwini from Sri Venkateshwara College of Engineering, affiliated to VTube. So welcome back to my channel. So today we'll see what is binary tree, transversal graphs and types of graphs. So first of all we'll see what is binary tree. Binary tree means it is a data structure in hierarchical data structures in which each node has at most two children referred to as left child and right child. So, it is commonly used as at most of children's in computer science for efficient storage and retrieval of data with various operations such as insertions, deletions, and transversals. A binary tree is a tree data structures in which each parent node can have at most two children. Each node of binary tree consists of three items, that is, data items, address or left child, address of the right child. So this is the types of binary trees, that is full binary tree, perfect binary tree, complete binary tree and squared binary tree, degenerate or pathological tree and balanced binary tree. So next we'll see what is binary tree transversals. Binary tree transversal is a process of visiting and accessing the each node in binary tree in systematic order. There are several methods of transversing in the binary tree. In-order transversals. Visit the left subtree, that is root node, and it is finally the right subtree. Pre-order transversal visits the root node and then left subtree and finally the right subtree. Post-order transversal visits the left subtree and the right subtree and finally the root node. So these are the transversals that can be implemented recursively or iteratively depending on the programming language that can be implemented recursively or requirements. So next we'll see what is graphs. So basically graph is a non-linear data structures consisting of vertices and edges. The vertices are sometimes also referred as nodes and edges that are lines or arcs that connect any nodes in the graph. More formally, a graph is composed of set of vertices and set of edges. The graph is denoted by G of E, V. Components of graph. Vertices are the fundamental units of graph. Sometimes vertices are also known as vertices or nodes. Every node vertex can be labeled or unlabeled. Edges. Edges are drawn used to connect two nodes of the graph. So in order pair of nodes, the directed graph and the edges can connect any two nodes in the possible ways. So they are no rules, sometimes edges. They're also known as anchors. In mathematical graphs, it can be represented in data structures. So we'll see what are the different types of graphs. First is directed graph. Directed graph is a which edge have directions. The edges have arrows indicating the directions of transversals, and a web page graph where links between pages are directional. It is defined as a type of graph where the edges have a direction associated with them. So next we'll see what is undirected graphs. Are graphs in which edges have no directions. That is, edges do not have any arrows indicating the directions of transversals. Example, it is a social network graph where friendships are not directional. An undirectional graph is a type of graph where edges have no specified direction assigned to them. Next, complete graph. We'll see what is complete graph. Complete graph is nothing but it is each vertex is connected to every other vertex. Example, a tournament graph where every player plays against every other player. A complete graph is undirected graph in which every pair of distinct vertices is connected by a unique edge. So in other words, every vertex is a complete graph of adjacent to all the vertices, and a complete graph is denoted by the symbol Kn, where n is the number of vertices in the graph. So this is complete graph. Next we'll see what is subgraph. So subgraph is nothing but it is a subset of vertices and edges derived from an existing graph. In simpler terms, it is a smaller graph that is formed by selecting a certain vertices and edges from the larger graph. So this means it is a selected vertices and the edges form a subgraph which retains the structural characteristics of original graph. A graph is a fundamental concept in which the structures plays a crucial role in various algorithms and applications. In this article, we will explore that subgraph is how it can be represented in the data structures. So these two are the subgraphs you can see where it consists of homepage, research, artificial intelligence, databases and data mining. So next is path. Path is a trailer in which neither the vertices or the edges are repeated. That is, if a transverse of a graph such that we do not repeat a vertex and nor we repeat an edge. As a path, it is also a trail, thus it can also be open walk. Another definition for a path is to walk is no repeated vertex. This is directly implies that no edges will be repeated and hence redundant to write the definitions of the path. So next, last one is cycle. Transversing of graphs such that we do not repeat the vertex nor we repeat a edge, but starting at the ending vertex must be same. That is, we can repeat the starting and ending vertex only when we get a cycle. Vertex is not repeated and edges will also not be repeated. So this is the types of graphs we have seen. So this is the cycle. So this 1, 2, 3, 4 indicates the cycle. So that's all for the video. Thank you everyone for watching my video. Please do share it to your friends and families. Please do like it. Thank you.